Now that we understand the basics of logarithms, let's look at the way they're used in real life with common logarithms.
Bring it on.
Let's try to solve this equation here for x.
Insufficient data.
Oh, it doesn't have a base. But here's what you need to know. In real life, when we don't list the base, we're going to say that we're going to use a base of 10 because that's the one we count with, base 10. So often, most of the time now, you're not going to see a base. It's going to be base 10. So let's rewrite this with a base of 10. So 10 to the third will equal x, and of course x will then be 1,000 in this case. So what you need to know is when they don't tell you the base, and most of the time they won't, the base is 10. Let's look at another.
Direction unclear. Please repeat request.
Here again we don't have the base listed. But we know when it's log, the log, it's the common log. The common log always has a base of 10. So you could even say, rather than log of b, you could say common log of b. Now, what is 10 to the 1.3? Use your calculator. 10 to the 1.3 is 19.95 approximately, and that's the way we'll solve that. Now if you look at your calculator, you'll see that there's no base listed on the LOG button as well. That's because that's a common log.
Allow me to demonstrate.
To use your calculator to find common logarithms, we're going to use this button right here, the common log button, LOG. You'll have to hit enter to tell it you're done typing the number. So if you type log, say 19.95, we just did a problem like that, and hit enter, what should we get? Well, we should have gotten 1.3, but 1.2999429 is approximately, because that's the way your calculator works. It always approximates, remember. Okay? So that's the button you're going to use to find common logs. Well, if you look below that, you see a button that's ln. That is also logarithm. But that's the natural logarithm of x.
Thank you, Mr. Know-It-All.
The natural logarithm uses a base of a number called e. E is a number that occurs very often in nature. That's all we'll tell you at this point. But it allows us to simulate many things in nature. Of course, only God can really do anything in nature. But e is approximately equal to 2.7182. It's like pi. It's an irrational number. We can never really write it down. So we just say e. So the natural logarithm has a base of e. And if you hit second logarithm of 1, of course that would be e to the 1th, wouldn't it? You would get 2.7182 or something very close. So to find a natural logarithm on the calculator,
Allow me to demonstrate.
we're going to use just a different button. We're going to use the natural logarithm button. Notice that it's very close to the common logarithm button, and we still need to use enter. So if you hit ln, or natural logarithm, of 2.71828, why did I pick that? What's the exponent you need to raise that to using a base of e? If you hit enter, we'll basically get 1, won't we? Because that is e.
I know that, dude.
Hopefully you understand that the common logarithm uses a base of 10 and the natural logarithm uses a base of e, which is 2.7 something. Consequently, the logarithm of e, the natural logarithm of e to the 13th, that's kind of a trick question. That means we're using a base of e. So what number do you have to raise e to get e to the 13th? Well, it's kind of obvious. It's like saying who's buried in Grant's tomb. what do you have to raise e to get e to the 13th? 13, quite obviously.
Please come again.
Now, what do we have to raise e to get the square root of e? A little bit more difficult, but remember, we're still using a base of e, even though it's not listed. We know it's e because it's the natural logarithm, the ln.
I'm trying to think, but nothing happens.
What exponent do we have to raise e to get the square root of e? Remember this exponent for the square root? You remembered. It's a half.
Houston, we have a problem.
What about other bases, though? Well, consider if the log base b of a equals x. Then, let's rewrite it in exponential form. The base b to the x equals a, doesn't it? Now, I've left a little room in there because I'm going to play a trick. As long as I do the same thing to both sides, it's fair. I'm going to take the common logarithm of both sides. The common log. Base 10, isn't it? I haven't listed base 10, but it's the common log, and it's as fair as can be because I've taken it to both sides. Now,
I know that, dude. Come on now.
I'm going to bring the right side down. The left side, I can pull a little massaging. What else? Where's another place I can put the x there? Remember the properties of logs? They're the properties of all logs. So I can put that x down in front. And now I can solve for x by getting rid of log of b, by dividing both sides by log of b. So, x x will equal the common log of a over the common log of b. And in fact, what we have here is called the change of base formulas. Notice we started with a base of b at the very top of the page here, and we ended up with what base? We don't list the base, so it's base 10. Now, why would we want to do that? Well, because our calculator can take a base 10 log, and we can actually calculate any logarithm of any base by using two base 10 logs.
Do you mind telling me what this is all about, mister?
Okay, let's use the change of base formula to figure out.
I'm sorry. I'm afraid I can't do that.
Yes, we can. Even though our calculator cannot calculate log base 100, we can change this using the change of base formula to the log of a over the log of b. Now, what is a in this case? A is the 10,000. B is the base, is 100. I always remember that b is the base. It goes on the bottom. Okay, a bunch of b's here. Base, bottom. So, this is actually going to equal
Perhaps I could be of some assistance.
the log of 10,000, the common log of 10,000 over the common log of 100. Now, I made it easy because these are going to be a base 10. You can figure them out in your head. The log of 10,000 is the exponent we would raise 10 to get 10,000. And the log of 100 is the exponent we would raise 10 to get 100.
Excellent.
That's 4 over 2. And if we reduce, the answer is 2. So, and of course we know 100 to the 2th power is 10,000. So it checks. This one we can do without a calculator. What if we wanted to find the log base 6 of 8? Once again, our calculator will only find logs base 10 and logs base e. So we can't find log base 6, but we can use the change of base formula. Okay, you just have to remember that the base goes on the bottom. So a is 8 on the top, and b is 6 on the bottom. So the log base 6 of 8 is going to be the log of 8, the common log of 8, over the common log of 6. And that you can figure out with your calculator. Hit log of 8 divided by log of 6. You could do the logs separately. Probably it's better to do it as on one enter.
No problemo.
And we get an answer. Okay? This is going to allow you, this change of base formula is going to allow you to find a logarithm of any base.
Thank you, sir. May I have another?
And the reason you'd want to do that is you may want to use that to solve equations like this one. In its current state, we really can't do anything with it. If we change it from exponential form to logarithm form, meaning that the log base 5, the exponent using a base 5 of the number 12, that's what x is, isn't it? Log base 5, that's the old switcheroo, of 12. Now we're going to have to find out a log with a base of 5. Now how can we do that since our calculator can't calculate log base 5s? We'll use the change of base formula.
Hey, that's just crazy enough to work.
The common log of 12 over the common log of 5. Once again, remember that the base number went in the bottom.
Now I use my secret weapon.
Now your calculator can calculate it because it can do common logs. And the log of 12 over the log of 5.
Transfer of data is complete.
How cool is that? You can find any log you need to. Okay, let's try another, just for practice. First thing we're going to have to do is rewrite it in logarithm form. So this is going to be x is the log base 3 of 7. Now I have to know what the log base 3 of 7 is. I'll use the change of base formula, putting the base in the bottom. It's going to be the common log of 7 over the common log of 3.
Perhaps I could be of some assistance.
Get out your calculator and tell me what the common log of 7 divided by the common log of 3 is. If you want to, you can do them as separate logs and then divide, or do it in one line on your calculator. You should get approximately
That's one small step for man, one giant leap for mankind.
very cool. Well, go out and calculate those logs.
Thank you very much for joining us tonight. We'll see you tomorrow. Good night, everybody.
Go do your homework.